Why sigmoid introduced in perceptron? Let's take a perceptron. H and W are the inputs to the perceptron, and A and B are the weights, and Z is the output. We know Z equal to A times of H plus B times of W, and what the condition is like, if Z greater than or equal to 0, then this H and B are from the label 1. If Z less than 0, this H and B are from the label 0. In this way it will works for the binary classification, but rather than that, they are introducing sigmoid, where Z equal to A into H plus B into W. This is the previous case. For that, they have introduced sigmoid on top of that. So Z value now, sigmoid has some, now they have changed the condition also. For Z greater than or equal to 0.5, label is equal to 1 with probability Z, and Z less than 0.5, label is equal to 0 with probability Z. So here they're not only saying which label, and they are saying with probability also. So how it works actually? Let's consider one example. This is our A into H plus B into W. If you took these 2 points and substitute in the equation, definitely it will be greater than or equal to 0. If you took these 2 points, it definitely less than or equal to 0. If you took this point, it is also greater than or equal to 0. But we can say this point definitely in the upper region with higher probability. Okay. So we have to introduce, like, we have to show the significance, like this has higher probability than this point. That thing we have to show. For that, we can do one thing. If we compute the just Z value, A into H plus B into W, like for this H comma W, if A into H plus B into W, it's a dot product of basically this plane equation. If we solve it's in mathematically we can represent in different way. We can represent A comma B dot product of H comma W. So we can write this plane equation as in this way: A comma B dot product of H comma W. So this A comma B will be on the perpendicular to this plane. We know in the plane equation H plus BW, A and B are A comma B. If you take consider it as a vector, it definitely perpendicular to the vector A comma B. So if we do dot product of this line and this line, definitely the point which is far away from the line has much higher value. Okay, so if it is higher value, it has higher probability. It is higher probability than the point which lies near to that. But still, for probability, the issue is like this infinite space. So the distance ranges from 0 to infinity. So if some point at distance x from the plane, x by infinity distance. So somewhat mathematically we couldn't use the distance technique because we couldn't say probability. When coming to sigmoid, actually sigmoid has probability. Sigmoid has a good thing, which is like sigmoid of anything, any value is lies between the, this is a sigmoid curve, this is 0, this is 1. So sigmoid has values from 0 to 1. This is 0.5 and doesn't have any negative values. It is always from 0 to 1. So now the z value will always be 0 to 1. So we can define whatever the z value. See, L is equal to 1 with probability of z. So if we get the z value of 0.7, then we can say at 70% probability the h comma w belongs to the label 1. If it is like 0.3, we can say at with probability 0.3 or 30% probability the label is in the could be 0. So that thing sigmoid can solve. Not only this, sigmoid also solves some other things. Basically, yeah, one more issue with the without introducing sigmoid is here, like if the points are like not linearly separable. See, in this region no linear line can separate the crosses and dots. So there is only one way. This is in this way we have to separate. So this is a curve, this is not a line. So when we introduce the sigmoid, actually sigmoid equation is sigmoid of anything is 1 by 1 plus e power minus that anything. So this value is not a linear curve. If you observe here, it looks like linear, but it actually the curve is, it is smooth curve. So it introduced non-linearity. So if you run any perceptron, if you run any algorithm, the algorithm can learn this non-linear curves also. So that is the one of the benefit. Yeah.